Welcome to our project. It is called the Teleoperated Actuating Plotter, acronym of TAP. Our main sponsor is Dr. Pandian, with our main professor being Dr. David Kubansky, and a special acknowledgement to Ching Ji. We have 5 students on our team, and with each differing levels of background in the engineering fields. Our main background of the project is the central line associated bloodstream infections. Nurses, whenever they are caring for a patient, they have to frequently adjust the IV pumps and change, for example, the dosage or which specific drug needs to go into the patient. And this creates repeated exposure events that elevate the infection risk for nurse and patient alike. During the COVID-19 pandemic, infection rates were significantly increased due to higher patient loads and staffing strain. And our main problem statement that we are solving is that there's currently no safe method for a nurse to go into a patient room and adjust the levels on the pump. Our main objectives of this project is to develop a precise XY plotter based actuator capable of reliably pressing buttons on the Alaris IV pump, which was provided for this project. Also, implementing a remote control software that converts user mouse inputs into accurate actuated motion so that a person can articulate the buttons on the pump remotely without actually entering the room.
Okay, so for our design process, we did a research, prototyping, 3D printing, and iteration and testing stages. We reviewed previous projects, data, code. For the prototyping, we did brainstorming and then CAD models. For the 3D printing, we 3D printed parts, and then came the iteration with 3D printing, where we 3D printed parts that were just meant for testing and just like to see what fit. And then we eventually got to final components. As for the testing, we had the wires out before we put everything together in its 3D casing to test the plotters, the XY motors, and the servos. But once the testing was complete, we put that into a final project or a final prototype and our final design. The final design that we came up with brought us 4 different things. First was the physical structure and mechanics. It used a two motors for the X and Y plotters, and then it used 2 servo motors as well. So because of that, we used a pi and then motor controllers to control those motors. Another conclusion that we drew from was our user interface. So we created a GUI for the nurse to be able to use the device remotely. We 3D printed most of our objects because of the budget. And then finally is the control. So all buttons can be manipulated by the tap machine using inputs from the user. The user interface can put in the inputs on the GUI and then be able to move the X and Y plotter to be able to push the buttons on the Alaris PC.
Some of our future considerations is adding a camera for live feedback. So currently one of our settings is a live motion, and we would have liked to add a camera so that the person controlling the machine could also see the screen, as currently that is unable to be done in a remote setting. Another part we want to do is extend the rails to the right and left so that the pushers can access the pumps on the side, which will allow further control remotely. Lastly, we would also like to, it would have been nice to be able to add a top and bottom clamp so that the Alaris machine and the plotter could be hung onto the IV poles where all the other machines and where this no machine is normally located.